To explain the basics of tray assembly, let's start with one part. We can go and get File, Print, Prepare for 3D printing of that particular part. Click on Auto Position and Assembly other parts. We can just place other parts, as many as we want, into the tray, even if those parts are not over the bed. This can be placed later using the auto positioning. We can also, as we will see, create some pattern to create multiple instances. For example, when you select one part and then just assign any method to define the pattern, then you select the number of parts. In this case, we are using direction. The only interest here for us is the number of parts. Then when we click on auto position, all the parts will be arranged inside the tray. Let's create another pattern to have multiple instances of this fuel cap. The next thing that we can do in the tray assembly is to create a nesting arrangement. The nesting, what we'll do is to place the parts as packed as possible in order to maximize the volume available in the tray assembly. We can use it in the case that the 3D printer can handle this kind of arrangement. The next thing is to create a note. The note capability here is just to document, is to create these notes to save some characteristics of the part, some instructions to the shop floor, because this tray assembly can be saved as an object for Creo view. All these notes are very relevant. The next functionality in the tray assembly is just measure. We can measure, for example, between one part and one of the sides of the tray, the box envelope. Other functionality in the tray assembly is the printability checks. Let's see an example where we are checking against the minimum wall thickness value, key in this case 0.7. We select the reference. There is one part, could be many, and in this case we are receiving the report that there is no thin wall value violation. But if we put a different value and check again, yes, in this case we have a problem, and we have the values and we can act. Let's take another look at another functionality to check that all the parts are correctly positioned in the tray. In this case, we make two parts intersect, click on global interference, compute a quick check preview, and the user will have the visual warning that we have some problems, some interference problems. We can return the part to the original positioning. Let's review the preview 3D printing environment. Here we can display the support material. It's a theoretical calculation of support material. We can also use a clipping functionality that is giving us the cross section. In some sense is the slicing, a progression. So the display support material is based on the draft angle that we key in, where we are showing on the screen. Also, something that we can do here is to modify the default Desolation parameters. In this case, we can see in this example, if we apply one particular value on the chord height, in this case this is very big, we can see that the triangulation is very very rough. Now if we can get a very small value, then accordingly we have a better definition of the shape based on the triangulation. This video covers only the basic functionality on the tray assembly. If you're interested in knowing more about the advanced tray assembly functionality, including the connectivity with 3D printers, there is another video of this series.